October 3rd, 2025. While NASA's official websites flicker offline amid a nationwide government shutdown, a green glowing interstellar traveler, 3I Atlas, races past Mars at 60 kilometers per second. For the first time in history, a confirmed object from another star system is crossing the red planet's orbit, and Earth can't even see it. Every ground telescope is blinded by the sun. Every American data feed is silent. Right now, only machines orbiting Mars, from Europe, the United Arab Emirates, China, and a skeleton team still monitoring NASA spacecraft, can witness the encounter. It is the ultimate cosmic irony. At the very moment humanity meets its third visitor from the stars, our own scientific voice goes dark. The clock is ticking. Within hours, 3I Atlas will slip behind the sun, vanishing forever into deep space. But before it disappears, a handful of cameras circling another world may capture the first close-up images of something that defies every comet rulebook ever written. It began quietly, almost too quietly for something traveling 60 kilometers per second. Back in early August, a handful of automated sky surveys noticed a fast-moving blur cutting across their nightly image stacks. At first, it was cataloged as another long-period comet, but the numbers didn't add up. Its incoming velocity was far too high. Its orbit not just eccentric, but hyperbolic, a mathematical signature of something not bound to our sun. Astronomers at the Minor Planet Center recalculated, ran the trajectory again, and froze. The object was inbound from interstellar space, and if projections were right, it would sweep past Mars in early October before disappearing forever. They named it 3I Atlas, the third confirmed interstellar visitor, after 1I Oumuamua and 2I Borisov. Yet even as excitement spread through observatories worldwide, the data raised uncomfortable questions. Unlike Borisov, Atlas showed no extended dust tail, no bright jets of vapor streaming away from the sun. Its coma, the gas halo surrounding the nucleus, glowed an intense emerald green, not white or bluish like most comets. And strangest of all, its spin and brightness barely changed over days, as if some internal force was stabilizing it. For veteran comet researchers, it made no sense. "It's behaving like a solid rock, not a melting snowball," one astronomer remarked. Others whispered comparisons to Oumuamua, the mysterious visitor that accelerated slightly without visible exhaust. Was Atlas another natural wanderer shaped by physics we barely understand? Or was it something else entirely, crafted, not born? From the first confirmed observations, 3I Atlas has refused to behave like anything known. The European Southern Observatory's initial spectrographs returned a profile that looked almost engineered, a sharp carbon emission at 518 nanometers, responsible for that unearthly green hue, but with chemical ratios far beyond any comet measured before. The brightness was stable, too stable. No flickering jets, no rotation wobble, no rhythmic outgassing. Dr. Lila Mendoza at the University of Arizona's Planetary Sciences Department summarized the dilemma bluntly. If this is a comet, it's breaking every rule in the book. Her team ran simulations showing that any normal ice-rich nucleus approaching this close to the sun should experience violent sublimation, shedding mass in visible bursts. Atlas didn't. Even after a coronal mass ejection slammed through its orbit in late September, its coma barely rippled. NASA's own modeling before the shutdown described a 5-kilometer-wide core wrapped in concentric shells of dust and gas, layered like armor. Polarimetry data hinted these shells might be discrete, separate events of ejection frozen in place. That geometry is unheard of in natural comet physics. Some researchers proposed the layers were simply coincidence, shaped by solar wind. Others quietly admitted that the spacing of the shells, regular, repeating, looked disturbingly artificial. Still, the mainstream view tried to hold. A team at ESA proposed that Atlas was composed of unusually refractory material, perhaps silicate carbon composites that resist solar heating. A more radical camp suggested it was not a comet at all, but a fragment of a shattered interstellar planet's crust, coated with complex hydrocarbons that scatter light in green. Meanwhile, the independent astrophysicist Dr. Ethan Reynolds pointed out a darker symmetry. The object's axial tilt, velocity vector, and approach plane all aligned within 3 degrees of the ecliptic, the same orbital path followed by Earth and Mars. Statistically, he wrote, that alignment shouldn't happen by accident for something arriving from another star. His paper, released hours before the government shutdown, concluded, if natural, Atlas is unique. If not natural, we just caught a probe masquerading as a comet. No one in the official agencies has endorsed that claim, but the data remain public, scattered across ESA servers and mirrored by citizen astronomers. And as each new spectrum arrives, the mystery deepens. Every explanation creates another contradiction, another hole in the model. What looks like dust behaves like metal. What should spin stays still. The question haunting the scientific community tonight is simple. How much of 3I Atlas can we still explain with physics? And at what point does the story cross into something entirely new? As the clock slides toward midnight on October 3rd, 2025, the geometry of the solar system performs a cruel trick on Earth. From our point of view, the sun now sits directly between us and the comet. The separation angle, less than 10 degrees, makes 3I Atlas invisible to every optical telescope on the planet. To look that close to the sun would burn sensors and blind instruments. For 6 weeks, stretching into November, the world's largest observatories must stand down. But Mars is offset by more than 40 degrees. From its sky, the comet hangs high, unobstructed, glowing faintly against the black. That simple orbital misalignment turns Mars into humanity's only window, our outpost cameras becoming the solar system's eyes while Earth goes dark. Across multiple control rooms, teams that normally study Martian weather or mineral strata have dropped everything. The European Space Agency's Mars Express and Trace Gas Orbiter pivot their instruments into deep space. Omega and Nomad, designed for atmospheric chemistry, are suddenly tasked with dissecting alien light across thousands of wavelengths. In Dubai, the Emirates Mars mission, HOPE, is granted emergency authorization to retarget its ultraviolet spectrometer. Even China's Tianwen-1 is looping data cycles to capture wide-field imagery from its high-resolution cameras. Inside NASA's Jet Propulsion Laboratory, the Mars Reconnaissance Orbiter could join that chorus if anyone were officially allowed to command it. The government shutdown means all public science feeds, from image servers to mission dashboards, are frozen. Internal safety teams keep the spacecraft healthy, but no public data leaves the pipeline. For once, America's flagship Mars mission is flying blind to its own citizens. And yet, beyond bureaucracy, the machines keep watching. Perseverance's Mastcam Z camera has been quietly collecting sky frames each Martian evening, 9-minute exposures tracking the thin clouds above Jezero crater. Tonight, those frames intersect with Atlas's predicted path. It's a one-shot opportunity, a single sequence that could capture history. Every orbiting platform is running in overload mode. Data buffers fill faster than they can downlink. Each transmission window is minutes long, the light speed lag between Mars and Earth stretching to 17 minutes. Engineers must choose, compress images and risk artifacts, or send raw frames and lose time. The stakes are enormous. If even one of those instruments catches an outburst, a spectral line, or an unexpected reflection, the data will rewrite textbooks, and perhaps the boundaries of what we call natural. For now, only Mars can see. The rest of humanity must wait in silence, watching proxy dashboards and mirrored amateur feeds, hoping the signal from the red planet makes it through. Scientists across the world are sketching out 3 scenarios, each more consequential than the last. None of them are comfortable. Scenario 1, the safe explanation. In this view, 3I Atlas is simply a colossal interstellar comet made of tougher material than anything seen before. Its green glow comes from diatomic carbon reacting under solar ultraviolet light. Its stability is a coincidence, a frozen, slow-rotating chunk of rock that happens to hold together better than expected. When sunlight fades, it will vanish into the void, never to return. Another statistical miracle written into the chaos of space. This is the story scientists want to tell. Predictable, contained, comforting. Scenario 2, the unsettling one. The data suggests something stranger, a hybrid object neither rock nor ice, its shell layers behaving like heat shields. The evenly spaced arcs seen in high-resolution imagery might record pulses of controlled ejection, not random outgassing. A few researchers whisper the phrase non-gravitational acceleration, a coded reference to motion powered by something other than the sun. It could be volatile jets beneath the surface. It could also mean internal energy release, a reactor-like burst, steady and deliberate. If Atlas follows this pattern, it might alter course slightly as it passes perihelion, an act no natural comet could perform. Scenario 3. The extreme hypothesis. This is the one most scientists avoid saying out loud. It begins with the near-perfect ecliptic alignment, within 3 degrees of Earth's orbital plane, and ends with the eerie constancy of its signal. Every measurement so far suggests purpose, a maintained orientation, an emission spectrum too clean for chaos. If that pattern continues, if new data shows rhythmic brightening, timed pulses, or structured radio noise, then the word engineered will no longer belong to science fiction. It will become the only explanation left standing. Between these theories lies a haunting silence. NASA's official instruments are still collecting, but the shutdown means no public comment, no live updates. Data packets may already exist inside encrypted archives, unseen. Meanwhile, independent analysts scrape raw telemetry from ESA and UAE portals, searching pixel by pixel for anomalies. The tension is global. Every orbit completed by Mars Express, every downlink from Perseverance, could tip the balance between ordinary and extraordinary. If 3i Atlas is natural, it will remind us that the universe can craft impossibly precise wonders on its own. If it isn't, then we have just witnessed the first close pass of something built elsewhere, something that crossed interstellar space and came within 30 million kilometers of a world humanity already calls home. Whatever 3i Atlas truly is, its passage has already rewritten the playbook of planetary science. The next time a foreign object enters the solar system, no one will accept slow bureaucracy or patchy coordination. The stakes are too high. A single delay, whether political, technical, or bureaucratic, can erase the only chance to record history. If Atlas proves purely natural, it still marks the moment humanity finally observed an interstellar body from the surface of another planet. That alone will change the way we design missions. We will place more instruments outward, on Mars, on the Moon, even in deep space relays, ensuring that no future visitor goes unseen. Every space agency will review its emergency protocols. The idea that a government shutdown could silence science during an event of cosmic importance will be studied in classrooms as a failure of policy, not of technology. But if the evidence tilts toward the extreme, if those concentric shells or steady emissions reveal engineered behavior, the consequences go far beyond astrophysics. It will become a turning point in human philosophy, ethics, and geopolitics. Who owns the first contact? Which nation or agency decides what the world can know? Would the data be locked away as a matter of national security, or released to all of humanity as a shared discovery? Behind those questions lies another, quieter one. Are we ready? For decades, space science has operated on the assumption that everything out there is indifferent. Rocks, gas, light. Atlas challenges that comfort. It hints that intelligence might leave traces not in messages, but in the physics of objects themselves. If the green glow is just carbon, our curiosity endures. If it is something more, an intentional signal encoded in chemistry, then the story of life in the universe begins a new chapter tonight. Either way, Atlas forces us to face a truth we often forget. The universe doesn't wait for our readiness. It moves on, with or without our understanding. While the headlines debate what 3i Atlas might be, hundreds of people, mostly unseen, are the ones keeping its story alive. In darkened control rooms from Madrid to Pasadena, engineers sip cold coffee and monitor telemetry that was never meant for this purpose. These are the night shift specialists, reprogramming orbiters and reconfiguring bandwidth on the fly, improvising observation campaigns during a government freeze. Their voices are tired but steady. We're still online? Keep the link open. In Tucson, a graduate student named Ava Patel runs image alignment scripts on borrowed server time, comparing each Mars Express frame with ESA's latest SPICE kernels. In the Czech Republic, an amateur astronomer with a backyard telescope scours old archives, looking for the earliest traces of Atlas before the Discovery announcement. Across the world, private citizens are hosting mirror servers to keep public access alive, quiet resistance against silence. Every raw image that escapes the blackout passes through human hands. Technicians validate timestamps, clean corrupted pixels, upload redundant copies before anything can be lost. It's a collective heartbeat of science, faint but unstoppable. Even as the official portals remain frozen, an underground network of collaboration has formed, connecting university labs, observatories, and online forums in real time. Somewhere between those cables and command prompts lies the essence of discovery. Not the equations or instruments, but the determination of people who refuse to look away when something extraordinary crosses the sky. They are the anonymous architects of truth, standing between curiosity and erasure. If a single frame from Perseverance confirms the streak, if one spectrum from Mars Express shows an impossible line, it will be because ordinary humans, students, analysts, engineers, kept their eyes open when the system closed. Long after 3i Atlas has vanished into the dark, their persistence will remain the quiet proof that knowledge cannot be switched off. By dawn on Earth, the data from Mars will begin to trickle home. Slow packets of binary light crossing 140 million miles. Somewhere in that stream could be the first clear image of 3i Atlas, the last glimpse before it fades into the void. Or maybe there will be nothing unusual at all, just another streak among countless cosmic fragments. Either way, the waiting becomes its own kind of revelation. Humanity has always learned about the universe through delay. We see stars not as they are, but as they were. We hear the echoes of ancient explosions long after the fire has died. Tonight is no different. While NASA's screens remain dark, and while politicians argue over budgets, a handful of cameras orbiting another planet continue their vigil. They record without ego, without borders, without sleep. If the first confirmed images show that Atlas is merely ice and dust, we will celebrate the beauty of natural order, the comfort that the cosmos still obeys its own rules. But if the patterns prove otherwise, if they show precision or intent, the question will not be, what is it? But, who are we to have finally noticed? Because maybe discovery is not about finding life elsewhere, but about recognizing that our own pursuit of knowledge, our refusal to stop watching, is life's most profound expression. Whether 3i Atlas is a comet, a fragment, or something entirely unprecedented, it has already changed us. It reminded us that even when silence falls, curiosity persists. Tomorrow, the first light from Mars will tell the truth. Until then, we wait, not in fear, but in wonder. Because whatever 3i Atlas truly is, it has already done the impossible. It made humanity look up again.